Hello, good day to all of you. I am Sarukar, an engineer who is responsible for the network monetization in IoT at ITMD Techo. So today I am going to give you a brief introduction about the IoT, which is Internet of Things. This is my today's outline. First, I am going to talk about what is IoT, then what are IoT technologies available up to now, and then I am going to compare some low power wide area network technologies. Then we are going to talk about the introduction to IoT, then IoT's overall solution architecture, then what are the advantages of it, and the, at Mobitel what are the spectrum bands we use for the IoT and the use cases for the IoT for businesses, as well as the finally future trends of IoT. What is IoT? As you all know, IoT means Internet of Things. What is this thing in Internet of Things? Actually, thing is basically a sensor. It has ability to sense its surrounding or control the device or do the both. Basically, a thing is a sensor. So if you look at this one, this is a smart bulb. Here what it does is that it presents the it detects the presence of human, and according to that it will operate the bulb. And this is the smart street lamps. Here what happens is that it will detect the presence of vehicle, and according to that the lamp will adjust the its light intensity automatically. So these are examples for things. These are basically sensors. So how a thing become Internet of Things? So actually IoT is a system of devices connected to the internet with the ability to collect and exchange data from users or environment with no human interactions. These things are connected to the internet for the purpose of exchanging the data from users or its environment without the human interaction. Then that is called Internet of Things. So now I know most of you are using these smart wearables. These are one example for these IoT and the AR glasses, and also the connected cars. These the main application of these connected cars will come with the 5G technology. So and also nowadays there are a lot of IoT applications. So mainly we can categorize these IoT applications into mainly 4 parts. One is consumer IoT, commercial IoT, industrial IoT, and infrastructure IoT. So to address all of these IoT applications, single technology is not sufficient. So currently there are several IoT technologies used for these kind of applications. Here this table shows some of the IoT technologies that are currently used. Here the x-axis represent the coverage range, and the y-axis represent the data rate and power consumption of each of these IoT technologies. Here in the lower left corner we have RFID, that is radio frequency identification. This RFID is mainly used for the tracking and monitoring of assets and objects. So typically they uses a RFID reader and receiver to track their devices. They use radio communication for the communication part. And also here the coverage range is low, as well as the data consumption and power is very low. Yes, these are used for the simple cases like the asset management, asset tracking, and the, mostly this RFID is used in the farms to track animals. And you already know what is meant by Wi-Fi. Wi-Fi can cover up to around 10 meters, and the data rate and power consumption is high. And the Bluetooth is also considered as one of the IoT technologies. And the BLE stands for the Bluetooth Low Energy. The main difference between the Bluetooth and Bluetooth Low Energy is the power consumption and data rate. They can both provide around 10 meter coverage, but when it comes to Bluetooth Low Energy, the power consumption and the data rate will be comparatively low than the Bluetooth. Actually, Bluetooth and Bluetooth Low Energy are used for small data transmission. We are not going to use Bluetooth for the many cases. And Zigbee, this is also one of the IoT technology used for the low power applications. Sometimes you may have heard about the Zigbee devices as well. And here we have our cellular networks. as telecommunication service operator, we provide 4G LTE, 3G, 2G, 4G LTE, and in near future, we will be able to provide the 5G as well. When it comes to these cellular technologies, you can see that we can provide a better coverage as well as the higher data rate. At the same time, the power consumption will be somewhat higher. You know, our mobile phones also we need to charge at least per day. That is because compared to these technologies, when we are using cellular technologies, it consumes more power than others. Here, we have licensed LPWAN and unlicensed LPWAN. LPWAN refers to low power wide area networks. So what is this licensed and unlicensed? Our radio frequency spectrum can be divided into two parts, licensed and unlicensed spectrum. This licensed spectrum is exclusively allocated for the mobile operators like us for our usage, and we have to pay a license fee for that. This unlicensed spectrum is shared freely and can be used by anyone. Here, under the licensed spectrum, there are two categories I have mentioned here. That is, one is LTE-M and other one is NB-IoT. Both two are subset of our LTE network. LTE-M stands for the long-term evolution for machine-to-machine communication. This technology can be used for the machine-to-machine communication as well as other technologies, NB-IoT, which stands for the narrowband IoT. This also can be used for the machine-to-machine communication. Here, under the unlicensed low-power wide area network, we have LoRa, long range for the long range communication, and we have for some application we use these LoRa devices as well. And Sigfox is a global wireless communication service provider that offers low power wide area network for the IoT, and they have their own proprietary network. Here at Mobitel, we are more focused about this NB-IoT. I am going to compare some low power wide area network technologies. Here I have considered LoRa, NB-IoT, LTE-M and GPRS. This comes under 2G GSM network. Here one of the main features I am going to talk about is latency. When it comes to LoRa devices, latency is somewhat higher, while for the NB-IoT, LTE-M and GPRS, the latency is somewhat lower than this. And when it comes to the spectrum, for the LoRa, as I told you, it uses the unlicensed spectrum, while all NB-IoT, LTE-M and GPRS use the licensed spectrum. And the coverage range. While LoRa devices can provide a medium coverage, this NB-IoT, LTE-M and GPRS networks can provide a better coverage than this one. And this is one of the main things. Here, if you are going to use the LoRa devices, you need the gateway like a Wi-Fi router or something. But if you are going to use the NB-IoT, LTE-M or GPRS, you don't need to. Gateway is not a must; it is optional. There is no need to use it, because in NB-IoT, LTE-M and GPRS, we are using SIM cards. We are using our existing cellular network. But here, we are not going to use SIM card. Therefore, intermediate gateway is needed if we are going to use the LoRa devices. And one of the another main feature of this low power wide area network is, as the name suggests, low power, the battery life of the devices. The battery life of the LoRa devices can withstand up to several years, as well as the NB-IoT and LTE-M, it can withstand few years, and for the GPRS, it can withstand up to several months. So, when we are considering a suitable technology for the low power wide area network, we are going to remove this one because here the latency is high, as well as we need the intermediate gateway. And if we are to use this one, the thing is that the battery life of GPRS devices will only last for several months. So we are not going to use these two for the low power wide area network applications. We mainly use this NB-IoT and LTE. Why is that? Here the latency compared to this one is somewhat moderate, as well as we don't need the intermediate gateways, as well as battery life can withstand up to several years. When comparing these two also, if we have to use the NB-IoT, we can keep the battery life up to 10 plus years. So low power wide area network applications at Mobitel, at SLT Mobitel, we are using this NB-IoT rather than this LTEM. The main difference between them is that here the other thing is that it can provide the throughput around 1 Mbps, and for the NB-IoT it can provide throughput around 250 kilobits per second. Usually, for NB-IoT technology is used for the low data rate application. So, when it comes to the low data rate applications, we are not going to use this one. However, we use this NB-IoT for those kind of applications. Now let's talk about actually what is this NB-IoT. First of all, I would like to talk about what is meant by bandwidth in a channel. Bandwidth in a channel means it is the range of frequencies that is used by a communication channel based of the size of the frequency that uses. Basically, we can categorize these signals into two parts. One is broadband signal, other one is the narrowband signal. Here you can see that the broadband signal uses comparatively large portion of available frequency spectrum, while the narrowband signal uses a small portion of the spectrum. Here NB-IoT it uses the narrowband because most of the time we use NB-IoT for the low data rate application. Here, if you look at this, the definition of narrowband Internet of Things, it is a low power wide area network technology, LPWAN technology, designed to enable efficient and cost effective communication for the Internet of Things devices using existing cellular network. This is one of the key reason why we are using NB-IoT, because to deploy NB-IoT we don't need separate additional infrastructure. We can deploy this NB-IoT on top of the existing LTE network. As I told you previously, LTEM and NB-IoT are two subsets of the available LTE network. Here, when it comes to the NB-IoT overall solution architecture, here, this is our terminal. Most of the time, this NB-IoT technology is used for the most common use case is the smart metering solution. So here, I have taken a smart meter here, and inside that smart meter, we can insert an NB-IoT module where we can put an NB-IoT SIM here. All of you have 4G SIMs. Similar to that one, we also have NB-IoT SIMs for these kind of NB-IoT devices. And after you insert the SIM, using the NB-IoT technology, it will connect to our base station, which is the cell towers, and after that, it will connect to our evolved packet core, which is our core network, and using the IoT platforms, which will be discussed by Mr. Hansen in his next session, we can manage all these all these devices in a one place. When it comes to the advantages of NB-IoT, the first advantage is they are very low cost compared to the existing 4G devices, and for a single network we can connect billions of connections. This will be very useful in smart agriculture like applications. And also the other main benefit of NB-IoT is that the battery can withstand 10 plus years. If we look at the smart water meter, it can't take direct power from the direct electricity. So we need to put a battery there. So that battery should withstand more years. Otherwise, we need to charge or replace the battery regularly. So that is not good. So that is why most of the smart metering solution we are using this NB-IoT. Other one is they are very easy to deploy, and also they have deep penetration. You know, when we go to basement, so ground floor, sometimes our normal cellular coverage is not there. But when it comes to NB-IoT, it can provide the deep indoor coverage as well. In the basements also, you can have the NB-IoT coverage, although you may not have 4G coverage. When it comes to the use cases of the NB-IoT for the businesses, I told you the most common use case is the smart metering, and for the asset tracking purposes also we can use this technology, and also for the smart agriculture as well as the connected parking solutions. And for the smart cities, actually this smart city will concept come with the deployment of 5G networks, and also for the healthcare monitoring and environmental monitoring, as well as the supply chain management. We can use the NB-IoT for these kind of businesses. This is the one of the most use case of the NB-IoT applications. Smart metering, smart energy metering or smart water metering. In Sri Lanka also we use smart energy metering using the NB-IoT. And what happens is that when we use the smart metering concept, they can automate their process very easily. They can the electricity utility can remotely manage their all the operations, so it will be very easier, as well as they can reduce the energy wastage as well. And also by now also most of the time they do the manual meter reading, but those will be somewhat inaccurate. But when it comes to smart energy metering, usually per day they will get at least one reading. So they can calculate accurate billing, as well as they can monitor each and every customer behavior as well, usage as well. And also these kind of solutions will help to improve the grid management as well. When it comes to future of IoT, it mainly comes with the deployment of the 5G. Actually, as Mr. Dilum said, one of the key concepts of 5G is massive machine type communication and ultra reliable low latency communication. With those two, the future of IoT will be rapidly evolving. And also, in future, with the deployment of 5G, we can create advanced positioning system, as well as there will be wide variety of use cases with the introduction of 5G. And also, with the help of 5G, currently we are using the IoT with the existing 4G networks now. So the data rate is somewhat low, but with the deployment of 5G, we can increase the data rate as well. And also, device support system will be rapidly evolved. And currently, for the smart metering also, what we do is we just get the data from the device and send to the cloud. The cloud is the place where all the processing happens. But with the 5G network, we can do the edge computing at the device level as well. Like AI and machine learning, all the stuff can be done at the edge level, and then we can send the process data to the cloud. It will save the transmission time as well. So that is all about the introduction to IoT and NB-IoT.